So you need to open the Ansys workbench and choose the fluid flow fluent, and then we have to make a new geometry design. Choose the XY plane and it will show you the direction of X, Y, and Z. And then you go to create and primitives and choose the shape of cylinder. Then you can add or adjust the desired length and diameter on the details view of the cylinder. After having put the numbers, then you can go on and generate, and this will be the cylinder that you will have. On the bottom part of the detailed cylinder, you can choose as a thin surface and choose as a yes, and then you can do generate. This will show the cylinder and the pipes will look like this. And then for the material added into frozen, we'll make the pipes into transparent so you can see the inside. Go on to tools and choose fill, and then click onto the inner part of the pipe and then apply. This will make the pipe into having two parts and one bodies. And we have these two solids, and choose the bottom one and rename it into fluid. And then you can see the difference between the solid and then the fluid part. For this, making the geometry is done, and then you can just save it and name it into your files or folders. And then we can move on to the next step is meshing. This is what you'll see in the meshing part. You can see that there's the statistics, and then you can update onto the mesh, and then it will generate the mesh. And here I am generating or changing the elemental size of the mesh, and then update it, and it will changes how the mesh look. It becomes more finer or in more smaller sizes. And since the computer does not know which is which, we can use the face tools and then name of each part, starting from the inlet and then wall, and then we can move on to the outlet. And here we have the name selections. We have the inlet, wall, and then the outlet. And then we're just gonna update it one more time to make sure that the mesh is successful. Now that the meshing is all done, we can go on to the next part that is set up or fluent. This is what you'll see on the fluent or on the setup. And then you can see that the gravity, we check off the box and then choose the number of the gravity as minus 9.81. And then we go into models and choose the viscose. I'm gonna use the laminar one. We can move on to the materials. For the fluid, I'm gonna change it from air into water. For the solid materials, we can leave it as it is, and then we can go on to the boundary conditions. I'm gonna choose inlet for the velocity inlet. And then moving to reference values, we're gonna compute from the inlet and choose the reference zone from the fluid. Moving to initialization, you can check off the distribute initialization and compute from inlet, and then you can start. Next to the calculation activities, I'm gonna auto-save for every 20 iterations, and then go to graphics and choose the path line. And here, we're gonna choose the view on velocity. And we're gonna focus from the surface of inlet, outlet, and wall. And then we can save. And to see whether what we've been doing is working or not, we can check on the pulse. And if it's moving forwards or upwards, then it means our work is correct. And then we can run the calculations and choose of how many iterations we want to have. The bottom white bar shows the progress of the calculations of the iterations, and here we have the graphs of the iterations. After the calculation is complete, we can go on to the result. In result, we can tick off the inlet and the outlet box. In this inlet and outlet box, we want to render the transparency into 0.90. Do the same for the solid. For the wall and the wall of solid, put the transparency into 0.90. Then we can select the streamline and select it to start from the inlet, and it will move towards the outlet. We can apply this and it will look like this. To see how it runs, we can move to the animation and select sweep animation. Choose the streamline and hit the play button, and this is what it will look like. In this simulation, we can see the particles is moving straight. Some of them are moving ahead while the others is on the back. This happens because in the center of the pipe, it has less friction, making it have a higher velocity than the other one that is closer to the edge of the pipe.